Welcome to Brain Vision.
Hey guys, let us do problem 23. In this problem, we need to calculate the production rate of dried milk, volumetric flow rate of the inlet air, and the upward velocity of air at the bottom of the dryer. So let us do this maths, and there are a few other questions that we need to answer. First, let's do this math. It is given that pressure of outlet gas pressure is 1 atmospheric pressure. Pressure of inlet gas is 1 atmospheric pressure. The volume of inlet is 0.0224 meter cube, and the temperature of the inlet the standard temperature 273 Kelvin, and temperature of outlet is 83 degrees Celsius. Let's convert it to Kelvin scale. It is 356 Kelvin. Okay, now if we consider the ideal gas equation, then the volume of outlet V2 is equal to P1 V1 T2 divided by P2 T1. Let's insert all these values. And the volume of the outlet is 0.0292 meter cube. Therefore, the molar volume of the outlet is 0.0292 meter cube per mole. Now it is given that the volume flow rate of outlet is 311 meter cube per minute. Therefore, the molar flow rate of wet air Therefore, the molar flow rate of the wet air is the volume flow rate of outlet divided by the molar volume of the outlet. Which is 10,650.7 mole per minute. Therefore, the molar flow rate of the wet air is 10,650.7 mole per minute. Now the outlet gas contains 12%. The outlet gas contains 12% of water. Therefore, molar flow rate of water is equal to 0.12 multiplied by the molar flow rate of air, which is 0.12 multiplied by 10,650.7 mole per minute, which is 1278 mole per minute. Now we know that 1 mole of water contains 18 grams. Therefore 1278 multiplied by 18 grams per minute, which is 23,005 gram per minute. Let's convert it to kg, which is then 23.005 kg per minute. Therefore the molar flow rate of water is 23.005 kg per minute. Now this amount of water, 23.005 kg water, is contained in 70% of milk. Therefore the molar flow rate of milk is molar flow rate of water divided by 0.7, which is 23.005 kg per minute divided by 0.7, which gives us 32.9 kg per minute. And now we can calculate the production rate. Therefore production rate of dried milk is X equal to molar flow rate of milk minus molar flow rate of water. Which is 9.86 kg per minute. Therefore the production rate of dried milk is 9.86 kg per minute. Next we need to calculate what is the volumetric flow rate of the inlet air. Let's do that. Now let's calculate the volumetric flow rate of the inlet air. The inlet air contains 12% of water. Therefore molar flow rate of dry air is equal to 1 minus 0.12 multiplied by molar flow rate of air. Molar flow rate of air is 10,650 mole per minute, which gives us 9,372 mole per minute. Now we know that molar mass of air is 29 gram, which means that 1 mole contains 29 grams. Let's convert it to then grams. Which gives us 27,000 2,715 gram per minute, or let's convert it to kg, which will give 271.51 kg per minute. Therefore, the molar flow rate of dry air is 271.5. This is one information we need. It is given that pressure of gas P is equal to 10 centimeter, negative 10 centimeter. Let us convert it to Pascal. Let us convert it to Pascal. Now temperature of dry air is given as 167 degrees Celsius. Let's convert it to the Kelvin scale. Which is 440 Kelvin. From ideal gas law, we know that PV is equal to nRT. Again we know that molar mass is equal to mass divided by number of moles, or number of moles is equal to mass divided by molar mass. Let's substitute it here. PV is equal to mass divided by molar mass multiplied by RT, or we can write V is equal to mRT divided by P multiplied by molar mass. This is the equation for volume that we can use now. So V is equal to mRT divided by PM, or we can rate the volumetric flow rate and molar flow rate. We can use this. The molar flow rate of dry air we just calculated is 271.51 kg per minute. The gas constant is 8.31 Pascal meter cube, mole inverse 1, Kelvin inverse 1. Temperature is 440 Kelvin. The pressure is 97,402.34 Pascal, and the molar mass of air is 29 multiplied by 10 inverse 3 kg per mole. Now if we do this calculation, we will get 351.6 meter cube per minute. Therefore, volumetric flow rate of the inlet air is 351.6 meter cube per minute. And finally, we need to calculate what is the velocity of air at the bottom of the dryer. We know that velocity U is equal to volume rate of dry air divided by the area. We know area is equal to pi r square, or pi d by 2, diameter by 2 square. We can insert this value, 351.6 meter cube per minute, 3. And here we can write pi d by 2 square pi is 3.14. The diameter given is 6 meter, which gives us 12.44 meter per minute, or 12.44 divided by 60 meter per second, which is 0.21 meter per second. Therefore, the velocity of the air at the bottom of the dryer is 0.21 meter per second. Okay, the next question is, it is 23b. The next question here is, engineers often face the challenge of what to do to a process when demand for a product increases or decreases. Suppose in the present case production must be double. Why it is unlikely that the flow rates of feed and air can simply be increased to achieve the new production rate. So why it is unlikely that we are going to increase the flow rate and feed air? The reason is the drying rate and the amount of drying will be affected by the time. The drying rate and the amount of drying is affected by the time. Therefore, the dryer will increase if more products are added to dried. Therefore, the flow rate of feed and air can simply be increased to achieve the new production rate. Okay, the next problem asks us, an obvious option is to buy another dryer like the existing one and operate the two in parallel. We need to give two advantages and disadvantages of this option. Now the advantages are, it is easy to double the production rate, therefore this would accurately and effectively double the rate of production. This would accurately and effectively double the production rate. This is one advantage. Another advantage is no stopping time would be required. However, there are disadvantages as well. The first disadvantage is it is not easy to buy, the cost will be high. And the second disadvantage is it consumes large space, so more space will be required for maintenance, for keeping it, and for maintenance more stuffs will be required.